Okay, we need to find the values of trigonometric functions. That's so hard for me to say that I just shorten it to trig. Okay, so we've got different functions: sine, cosine, tangent. I'm going to look at those first, and then these other ones: cosecant, secant, and cotangent. Okay, so let's just look at sine first. So sine is defined as the y value, as the y value, okay, of a terminal point, Okay, so for example, here I have a location on the unit circle, so it's negative, so I'm going to go back, and I'm going to go back to negative pi over 6, okay? So now is where it's really nice to know all those terminal points on the unit circle. That is at square root of 3 over 2 and negative 1/2. So I have an x and a y value. And the sine, we're just being asked to write down what the y value is there. Okay, so sine a value of negative pi over 6 has an answer of negative 1/2, and that is what we're being asked for there. Okay, let's try another one. Let's do cosine of negative pi over 6, and that's just the x value. Okay, so that would be the square root of 3 over 2. Square root of 3 over 2, and that is done. Okay, so let's work on tangent. Let's see. Okay, so the tangent, the way we define that is that tangent is, so that was cosine that we just did. Okay, and so tangent is defined as y over x. So let's get started on that one. Okay, whoops, jiggly. Okay, so tangent at negative pi over 6 is going to be y, which was negative 1/2, over x, which is square root of 3 over 2. Okay, and now that I'm just going to, we have fraction divided by fraction, so I'm going to take negative 1/2, and instead of dividing by a fraction, I'm going to multiply by the reciprocal of the denominator. And then that would simplify to negative 1 over root 3. And then we do need to rationalize that denominator. So that one is negative root 3 over 3. Okay, so there's my tangent. Okay, we've got a couple more to go. Let's do our cosecant. Okay, and that is defined as 1 over y. All right, so cosecant at negative pi over 6 is 1 over y, and y was negative 1/2. And that would be 1 divided by a fraction, so I'm going to multiply by the reciprocal, which is just negative 2. Okay, but do you see how the reciprocal of negative 1/2 and 2, those are just reciprocals of each other. So another way of writing cosecant, cosecant of some t is the reciprocal of sine. Okay, so if we did all the work of finding our sine, the cosecant, we can just flip that upside down and we've got our cosecant. Okay, and the same thing with the secant and the cosine. Okay, so secant at negative pi over 6 is just the reciprocal. We just flip this upside down to get our secant. All right, so 2 over root 3. And then you do need to do your rationalizing. So it'd be 2 root 3 over 3. And there we have it. Okay. And then the one that's always a little bit harder is tangent. So our cotangent, our cotangent at negative pi over 6. Okay, it needs to be the reciprocal of what we just found for tangent, so 3 over negative root 3. And then we'll simplify that, rationalize the denominator. And so we'd have 3 root 3 over negative 3, and our 3's divide to 1, so it's just negative root 3. And that is how you find and evaluate your 6 trig functions. And so it all comes back to the terminal points on the unit circle. Okay. So just so that we have it formally in your notes here, the reciprocals, identities, we can always think of cosecant as just 1 over sine. We can think of secant as 1 over cosine, and tangent as 1 over t. And then tangent is defined as y over x. And since sine is y and cosine is x, you could also think of that as sine over cosine, and likewise with your cotangent, because cosine is x and sine is y. So really sine and y, those are the same. Cosine and x, those are the same, okay? On the unit circle. There we have it, learning how to find the values of trig functions on the unit circle. Okay, let's do one more example. We need to rationalize that negative square. All right, I'm going to do 4 more of these. So let's see, sine at 5 pi over 6. Okay, so at 5 pi over 6, this would be pi, right, which is 6 pi over 6. So 5 pi over 6 isn't quite there. So we're at 5 pi over 6. Our x is negative here. So negative square root of 3 over 2, positive 1/2. The sine is the y value, so that is 1/2. The cosine is the x value, so negative square root of 3 over 2. And the tangent is y over x, so that is 1/2 over negative square root of 3 over 2. Take the numerator, multiply by the reciprocal of the denominator. And rationalize it, so we'd have negative square root of 3 over 3. Okay, so there it is. It's all about knowing where we are on the unit circle, what the terminal point is, so what the x and the y values are, and then putting it together. Notice in quadrant 1, we have a positive x, positive y. So tangent, sine, all of the trig functions are going to be positive. Okay, now over here in quadrant 2, the x is negative. Okay, so we have a negative x, a positive y. So the sine is positive, right? But the cosine, anything having to do with x was negative. So the only thing positive over here is just sine. And then over here, since it's negative x, negative y, in this case, if you had x divided by y, it'd be positive. So tangent's positive, everything else is negative. And then here in quadrant 4, let's see, that was quadrant 3. In quadrant 4, the x is positive. We have a positive x and a negative y. So cosine would be positive. Anything having to do with x is positive. So cosine and let's see. Okay, some people, it helps to remember all students take calculus is a little mnemonic to help you remember. It goes like this: all students take calculus. Just the okay, let's see. We're going to do tangent of 2 pi over 3. Okay, so let's draw that out. Okay, 2 pi over 3. 1/3, 2/3, so 2 pi over 3. And our points there are at negative for x and positive for y, root 3 over 2. And so the tangent is 2 pi over 3. Okay, and the tangent again is always y over x. Okay, and so we'd have y is root 3 over 2, and that's being divided by x, which is negative 1/2. And so we can rewrite that as the numerator times the reciprocal of the denominator. So this is negative square root of 3. Okay, I just want to point out one more thing here on our domain. The domain for sine and cosine has no restrictions at all, but for tangent and secant, because tangent is y over x and secant, well, that's t, is 1 over x, we have problem areas when we have x is 0, which happens right here at pi over 2. And then also that would happen really any multiple of pi over 2, because that point is at 0, negative 1. Okay, so we have to look out for any multiple of pi over 2. Okay, and then for our secant, or for our cotangent, cotangent is x over y, and cosecant is 1 over y. And so we've got problems there if we have y being 0, which happens here at pi, or at 0 and 2 pi. Okay, 0, and then really any multiple of pi, because we go here at 0, here at pi. What's our y value there? Well, it's 0. All right, so we've got undefined whenever y is 0 for both cotangent and cosecant. All right, and now just a few words about tangent, just so you don't have to do quite so much arithmetic simplifying those. I just want to point out here that tangent is 0 along the x-axis, so at 0 and at pi, and it's undefined here at pi over 2, or any multiple of pi over 2, like we just talked about. Okay, and now it's 1 right here, where the x and y are the same because it's a fraction, a ratio of y divided by x. So if they have the same value, which happens at any multiple of pi over 4, we've got tangent being tangent, all of these, the output of tangent is 1. It's just negative 1 in quadrant 2 and 4, because the signs of x and y are different. Okay, so, and then really you're just having to memorize and think about these locations here. Okay, so tangent at pi over 6 is root 3 over 3, and tangent at pi over 3 is root 3. And the way I remember that is that we have a smaller, pi over 6 is a smaller number, and root 3 over 3 is a smaller number than comparatively root 3. If you split that, you know, root 3 divided by 3 is smaller. Okay, and pi over 3, that's a bigger value than pi over 6. So bigger t, bigger output. Okay, so really you're just having to memorize, you know, those two. And if you can memorize all of your trig functions in that first quadrant, you're really good to go. Because the only thing that changes in the different quadrants is cosine might be positive or negative in different, you know, depending on where x is positive or negative, and sine is positive up in those upper quadrants 1 and 2 where the y values are positive. There you have it.